Hey guys, today we're going to introduce the idea of systems of equations. Okay, first we're going to solve systems of equations graphically. That's the second half of this chapter, is systems of equations, and the graphically is one way of doing it. Graphically means graphing the system. So we need to remember how to graph one equation. Okay, y equals 2/3 x minus 1. So I have to start on the -1, and the slope is telling me it's positive, so up and to the right. So up 2 and 3 to the right, up 2, 3 to the right. Okay, and that's how I'd graph. So a system of equations is where I'm going to draw another line over top of this one, and I want to see where they cross, basically. So our notes in class: a system of equations is two or more equations that have one common solution. To find the solution, you graph both lines on the same coordinate plane and look for where the lines cross. Okay? So we'll do a couple of these, and then I want to talk about the homework situation. There's a couple on the homework I want to talk about, and we'll go from there. Okay, if you are my student and you feel comfortable enough, you can, you don't have to write the m and the y-intercept separate anymore if you feel comfortable doing so. Okay, if you know that, well, I'm just going to start on +5 and you don't feel like you have to write it down, well, you can do that. Your slope here is -1. If you don't feel like you have to write it separately, you can just annotate it from the equation. You can do that. Remember, we want a fraction, so if we don't have a fraction, we put it over a 1. If I don't see a number in front of the x, I put a 1 there. Negative sign means go down 1 and 1 to the right. So down 1, 1 to the right, down 1, 1 to the right, down 1, 1 to the right, and so on till I get to the edges. And then backwards, up 1 and 1 to the left. Connect. Arrows. And label. Y equals -x plus 5. Okay? Then we have our second equation. It says to start on -1. And the slope is a whole number, so I'll again make that into a fraction. It's positive, so I'm going to go up 2, 1 to the right. So up 2, 1 to the right, up 2, 1 to the right, up 2, 1 to the right. Come back to the middle, down 2, left 1, down 2, left 1, down 2, left 1. Arrows and label. Now, that doesn't seem like anything new. All we did was graph two lines, but on the same picture. So here's where the new part comes in, and it's not hard. What I'm looking for is this area right here where the 2 points intersect. And my solution is the coordinates of that point. So I'm going to write it in coordinate pair form, 2, 3. Now, the order of the numbers is really important. You always put the x term first and the y term second. So the x is 2, because this is the x-axis. The y is 3, 2, 3. Okay, that's very important. Let's do another one. Okay, so this graph starts on +2, and negative means go down 3 to the right. 1 down, 1, 2, 3 to the right, 1 down, 1, 2, 3 to the right. Go back to the center, go opposite, up 1, 3 to the left, up 1, 3 to the left, connect, arrows, label. Now we'll go to our other graph, or our other equation, excuse me. -5 is our starting point. 2 over 1 up to 1 to the right, up to 1 to the right, up to 1 to the right, up to 1 to the right. And down to 1 to the left. Don't have too many to go in the opposite direction. Connect, arrows, label. Really important now that you label so that the readers of your paper, i.e. your teachers, know which graph you intend to be which, especially if you make a mistake. It helps us to know what you were intending to draw when you've made a mistake. So here's my point of intersection. That's my solution. So 3, 1. In that order. You cannot reverse the order and put 1, 3. The x value has to come first. Okay, now there's a special situation that's going to come up where you'll get no solution. So check this out. Let's graph the first one. Starting at 1, the slope is 2 over 1, so up to 1 to the right, up to 1 to the right, up to 1 to the right, up to 1 to the right. Okay, down to 1 to the left, following that pattern. And label. Okay. Now, I've told you this one is special, but we're going to pretend we don't know it's special. We're just going to keep going. All right, -3 is our starting point. And this is also up to 1 to the right. All right, I'm looking at the picture and a special thing has happened. Y equals, I've arrowed, connect, -3. Okay, wait a second. I was looking for where they cross, but these lines don't seem to cross. In fact, they are parallel. So when I see parallel lines in a picture, I know there are no solutions because they're never going to cross. Well, wait a minute. How is it that they ended up parallel? Okay, and could I predict that that was going to happen? Well, our first bullet says that the slopes match. Okay, notice we have a slope of 2 here and a slope of 2 here. In both cases, we went up 2 and 1 to the right. Okay, so it's kind of like, you know, you're running a race and somebody gets a head start. And if they have a head start and you run the same speed that they do the entire race, you're never going to catch them. Okay? So these are never going to cross. There are no solutions. All right? They have different y-intercepts. Okay? Whoop. They have different y-intercepts, but they have the same slope. Equal slope, different y-intercepts. There's no solutions for that. Now, preview. Some of you, if you don't have me, I tend to save the other situation, which is where there are infinitely many solutions. I save that for lesson 3.7. Okay. So I will talk about it in class on Monday. However, if you are not my student and you're wondering about infinitely many solutions. Infinitely many solutions would be if my slopes match and my y-intercepts also match. If they overlap, if the blue line and the red line were graphed right over top of each other on the exact same dots. Okay, so let's look at some homework. Because what's happened is that some of you are looking at this one right here, y equals 3, and you're like, what the heck? How do I graph that? Okay, well in class, I gave you some kind of silly words to help you remember what to do if you see a y equals a number line. And the silly word for it is hazy. Doesn't have any mathematical meaning. It doesn't, really mean anything for lines, but it does have some letters in it that stand for things. Like the y stands for y equaling a number, like y equaling 3. The z stands for 0 slope. H stands for horizontal. A is just in the word to make it a word. Okay, without the A, it would be just hizzy. That's not a word. Okay, so what you do to graph this is go to the y value of 3 and draw a horizontal line. Horizontal line. In fact, I'm going to extend that out just a little bit with my arrows. Okay, so then when I'm graphing my second one, starting at -1 and then up to 3 to the right, up to 1, 2, 3 to the right, up to 1, 2, 3 to the right, okay, I can see my intersection point is right here, which is, now there's no number here, but it's, 6 comes after 5, so 6, 3. Okay, so that's number 1, all done for you. All right, number 2 I'm only going to partially do. All right, so number 2 says x equals a number. Well, that's different. That's not a y equals mx plus b. Again, this is one of those cases where I've given you kind of a funny word to help you remember what you're supposed to do, and it's vixen, like the reindeer. So x equaling a number tells you you have an undefined slope, or you can also say you have no slope. But for me, no slope and 0 slope sound too similar, so I like to make it sound different. And the V helps you to remember vertical. I and E don't do anything, they're just there to make a word. Okay? So I go to the X value of 2 and I draw a vertical line. So don't forget hazy vixen. That's there to help you remember how to draw y equals a number lines and x equals a number lines. Now, I'm not going to do it in the video, but you have to then go and graph this line over top of the blue one and see where they cross. So you still have to finish this one on your own, but I wanted to get you started on that. Okay, have a great time, and I'll see you next time.